Okay, don't know what happened there. The stream just died. What on earth happened? Yeah. The stream ended for some reason. That was weird. Maybe I pressed the keyboard shortcut for it? No, I couldn't have. Okay, that was weird. And I just realized I didn't even expose the anchor thingamajig to the editor. Okay. Yeah, I'm wondering why that happened. I'll have to keep an eye out and see if it goes down again. I'm just gonna not bother. So this is toward positive C. If we simulate, let's maybe try doing that. See what happens. Okay, that does seem to work. 0.5. Yeah, and then maybe up a bit, because for some reason it's calculated weirdly. No, 0.5 was correct there. And I think in the case of primitives, 0.5 will be correct almost all the time. Except for maybe the y-axis. Yeah, definitely not the y-axis. Although, I mean, we're not accounting for like any proper scaling stuff. Yeah, but that looks correct. So 0.15 and 0.5. Just gonna make sure we're serializing that. It would obviously be nice if we could like automatically calculate these sorts of things, which I imagine is possible, but probably very difficult. So you'd have to get the common kind of midpoint almost between the two, and then you'd need to have that as sort of an offset in local space from the parent, which, to be honest, probably isn't too difficult. We should probably have an option to do that. At least if you specify like 0 as an anchor position. Or maybe have an option to, like, they automatically calculate anchor position or something. But you may not want it in all directions. Because if I go in here, no, here, we do 0.15 and 0.5. Well, no, I guess we would probably maybe want that in some cases. Let's go in here, edit. We will add option to automatically calculate anchor position. That's presumably something we'll want. Okay. Either way, let's start testing this. Now this is apparently invalid for some reason. What if I swap them around? Like that. That works. And that is with the hard limit on. If we go and enable the smooth contact resolution, it's way smoother. Cool. Now I'm curious, like, what if I move this, say, here, and we set this back to 0? Yeah, it's not working exactly the way I want it to, but I mean, it's working at least, and I have problems with the blue, so let's get it sort of closed there. Cool. Now, obviously Revolute joints have a lot more parameters that we can play with. They support, go to the components, like motor driving, And also mass scaling we probably want pretty soon, because that is important to take into account. So apparently these should be flipped by default. What's that? What's that? I'll also add an option, a thing here for properly calculate joint local rates. So that's the limit, and we also have motor, which drives the relative angular velocity of the reaction towards the specified target velocity. Let's actually go ahead and just add that. Enable motor. And what parameters do we have? The target velocity. Target motor target velocity. We can also say drive limits are forces. Sure, let's go with that. Let's serialize that. But I'm probably going to be working quite a lot on this in the coming months, because there is quite a lot that I need to take care of before rigid bodies are feasible, and then I'm probably going to spend a lot of time tweaking it and making it just be perfect. Motor target velocity. Then it was drive limits are forces, which I should probably call like motor drive limits. Oh my god. Okay. Let's do the same kind of thing we did with this. The rotational limits. Yeah, we can just copy this entire thing motor settings. Get rid of that. Motor settings. And then we want the target velocity. And whether we use those as forces, whether to draw limits as forces, or an impulse. Forces. And I'll add some tooltips to these eventually. For now, I'm just trying to get it to work. Okay, good. When we come into here, we need to check set drive velocity and relief joint flag. So if, I mean, we don't even need an if, technically we can just do join set revolute joint flag. Drive enabled. Drive velocity. Oh, okay. Motor target velocity, which this will be set as sort of the initial one. I imagine this is something you can update through C# code to keep it spinning if you wanted to. Now I did see pre-spin. If the existing velocity is beyond the drive velocity, do not add force. Right. So we can add another option. Motor free spin. Not necessarily the best name, but whatever. Pre-spin. Maybe it should be enable motor pre-spin. I think it should be. Why won't it let me do the renaming? What? Okay, here it will let me do that. Enable motor free spin. Yes. Enable. Cool. We'll have another one. Enable refund. Cool. Let's give that a quick test. And I think once I'm done with that, I can probably just tick this box and then start working on these, but I'm not sure if I'm gonna do that today. We'll see. I'm not looking forward to implementing a T6 joint. I mean, I sort of am, but sort of not. I think at the end of this sort of journey of Ragdoll, I'm pretty sure it's gonna be like the most difficult thing I've done in physics. Because joints are complicated. Well, some joints are complicated, others are dead easy. So if I go ahead and enable the motor, and we set a target velocity of -5, maybe? And we hit simulate, it spins backwards. -0.5. Yeah, it still spins backwards. I'm wondering, like, is there a value that I can set here that will make it so it doesn't spin at all? No, and I think the reason for that is we don't have mass scaling. Mass scaling. May apply scale to the mass and moment of inertia of the two connecting bodies for the purpose of resolving a joint. For example, you do. Okay. How do I do that though? Is it this inertia scale? Possibly. Yeah, that's not even a thing that gets called. This is gonna be interesting. But I think the mass scaling is what's done here with the mass phase inertia tensor and the inertia scale. Maybe. I would imagine so. Samples. Bridges. Does that use joints in any way? Joints. It does. Injection linear tolerance. Hang on, here they take the scale into account. We don't do that. We never take scale into account when we calculate our local frames. What I'm considering doing is, instead of pausing in the actors, I'm gonna pause in the world transforms. Because then we can just take the inverse of the entire thing. Let's try that. Patrick Astro Killer, thank you so much for following. Parent world transform. World transform. And the anchor position. Because this means we can straight up do the inverse of parent world transform dot transform and child world transform get transform. And hopefully this works. And hopefully it works better than what the other solution did. Oh, I forgot to update the places where we call it. Scene. Yeah, world transform parents. And for the child. Because if you take scale into account, then I think it should be a lot more accurate. Hopefully. Well, I mean, it should. But maybe only the translation and rotation should be inverse, not the actual scale. Because I think in here they do... Yeah. They... Oh. Or maybe not, I don't know. Let's just try it. First of all, let's go ahead and zero out these, and let's disable the motor. Let's also, for the purpose of this, disable the limits, although I can already tell that did not look correct. Yeah, that doesn't look correct at all. For some reason. Okay, let's do this. Translation, rotation, scale. Decompose the parent world transform into translation, rotation, and scale. We'll then do an inverse of translation, which takes a is it the rotation or no, it's rotate. How is it we compute that? 2 mat 4 and then in a quaternion. Okay. 2 mat 4 rotation like that, multiplied by scale. Maybe. Then we need to do the same thing for the child. Fail. 8. Oh, wait. Now it should work. I have no idea if this is gonna work. Or if taking the scale into account is even correct. Like, I don't think the scale should play into this, but maybe it does. Yeah, that's not correct. TPXJZ, thank you so much for following. What if I do this? Yeah, see, I think taking the scale into account just does nothing, effectively. Which means we don't need this at all. It at least seemed like it was doing nothing. Hazel UI looks so good now. Yeah, it looks really good. Like, compared to even something like Unity, I think it looks a lot better. Although, probably Unity has a lot more kind of UX testing and stuff like that. But it definitely looks great. Why did you fail? Motor free spin is... What? UE5 wipes. Yeah, we definitely took inspiration from that. Uh-huh. Okay, so they've just hard-coded some stuff into here. Offset, which is the separation divided by 2. Yeah, I think we should be calculating like the offset. And then they call this using either offset or T. So if we have a previous, so for the first one they do, the first chain they do T, for the other ones they do offset. And then a negative offset there. So offset for the parent, and negative offset for the child, which makes a lot of sense. I mean, we can do that pretty easily, I think. If we go back to having the world transform here. Because then the offset would be 1 minus the other divided by 2, and we would do negative for 1 and positive for 1 for kind of this, I think. Or for just this. Although you may not always want the exact same way of calculating this. Now that I think about it. Because this is literally how easy it is in the case of like a chain. Okay. I will only be using the actual translation here. And it shouldn't be the inverse. So let's store this. And transform. Rotation, and scale. Translate. No. Transform. Alright, we'll do a offset, which I guess depends on which one. Will that be translation minus translation minus child translation, or the other way around? Could be the other way around. But we do that, then we divide it by 2. And for match for local frame, which needs, yeah, we do the parent inverse transform multiplied by, oh, Philip Trudeau, thank you so much for the raid. Hope you had a good stream. Danny the Vimmer, thank you for the follow. Philip, thanks for the follow. Much appreciated. Okay, so the parent and the positive offset. Really be good. Thank you for following. Let's actually zoom in that a bit. Translate this by the negative offset. Everything. Local frame. Local frame. I have no idea if this is correct, but it does mean we will automatically be calculating the joint offset. Hello, L, I, thanks for following. Silver X, thank you for following. Man, every one of Philip's dudes be supporting. Okay, so we've tried this. I think the offset is wrong. The offset doesn't look quite right. So maybe it's child minus parents. Potentially. always like to show some support for programmers using C, C++. Yeah, it's a nice language. Well, it's a messy language, but it's fun to write, I think. I really love working in it. Ugh. Please work. Yeah, no worries, man. Okay, so I mean, that's obviously wrong in so many ways. I'm thinking it's because we don't have scale accounted for. Again, I will say this, I am not good at matrix maths. I suck at dealing with matrices. Maybe we need to do an inverse on this. Inverse all the things. Okay. What about this? Oh, come on. It's not helpful. Well, yeah, that's even worse. I mean, I think one of the issues is the fact that the global post doesn't know anything about a scale, right? Which means we end up with the wrong scaling. So arguably, these should in fact take in a transform component. Transform. Transform. That's a long line of code. And this makes it so much easier because we can do transform, get transform. We may want the inverse transform to not account for scale, but transform translation. Whoa. Multiplication. That's not right. Translation. Get out of bed, but best of luck with physics works. Thanks for the stream. No worries. Thank you for the raid. Seriously, I appreciate it. Actually, I think what I want to do here is store this again, because I need to decompose it in order for the scale to properly affect the translation, I think. and translation, vacation, scale. Compose the current transform. Yeah. This may need to be its own matrix, but for now we'll just try this. And I need to update all of the code. Get world space transform for parent. There we go. I'm actually really tired. I only slept like 5 hours tonight, and I spent pretty much, what, 4 hours yesterday in a car. So I'm probably missing something obvious here. Yeah, I mean, again, that doesn't look correct in any way. This should not be this difficult. You'll get offset matrix between two matrices or something. So you do the inverse Is that what I want? What is this? Parent minus parent divided by 2? What? Like I said, tired. Child minus parent? Yeah, that's not correct. Because the way they do it is the offset is the separation divided by 2. Local TM, which, okay, that's not really. Because they just specify a hard-coded separation here. Yeah, to be honest, I'm gonna probably just go back to what it used to be for now. I'll probably end up calculating, like, trying to get the actual automatic offset to work. Later on. Because I think I'm just too tired of dealing with that kind of matrix math BS. So, but the Revolute joint is implemented. All the actual functionality is there, it's just the anchor position isn't quite correct. Which is incredibly annoying. Also, like, I'm not sure, I could kind of approach this in 2 different ways. The way I'm doing it currently, which is basically testing it using primitives, or I can immediately start trying to get it to work with skeletal meshes, because that gives me access to the bind pose, which I can use for I can actually use bind pose with the joints. I think. Yeah. Because that's used as effectively the joint location. And I mean, this just wasn't working. I don't know, actually, maybe this is correct, but I just was passing in the wrong stuff. Tell you what, before we do anything else, let's give this a go. So, I can't actually remember where I got this code from. Well, because this only does it for one, though. Yes, I don't think that's correct at all. I think this is something I'm gonna have to do quite a bit of research on, just to find out like how other engines handle it, and kind of what the proper way of doing it is, in such a way that it looks good. So yeah, I'm probably gonna go ahead and push this and then end the stream after that. I'm probably not gonna be streaming tomorrow because I want to do some research on this properly. But on Monday, in fact, I'm probably gonna try and stream as much as possible next week. Just gets a lot of this done. But I did get some work done today, which is nice. Finish implementing Revolut joints. We added, well, first of all, with fixed rotation limits being inversed, added joint motor support, which is, you know, dead easy. Semi-fixed local frame calculations. It requires a manual offset to be specified in some cases. Row joint component is now copied properly. Cool. Let's push that, and then I'm gonna merge dev into Ragdolls and push that. Because dev has had quite a lot of work on it. Merge. Oh, that's nice. You can auto merge. Let's also push this scene. Forgot push scene pages. Whoa, that zoomed in. Cool. Okay, well, I'm gonna go ahead and end the stream here. Like I said, I won't be streaming tomorrow. I'll be doing research, and then probably next week I'm gonna be streaming almost the entire week, except for Wednesday probably. So, but yeah, either way, thank you to everyone who tuned in. Appreciate the support, and see you next stream.